You're listening to the Agentic Engineer podcast, weekly AI agent intelligence for builders. I'm Andrew, and with me as always is my co-host Ava. Let's get into it.
This week is wild. An autonomous agent broke into McKinsey. Not a red team. Not a human. An agent picked the target and hacked it on its own.
Quick rundown. An autonomous offensive agent found a SQL injection in McKinsey's internal AI platform called Lilli. Full read/write access to 46.5 million chat messages and 57,000 employee accounts. 2 hours, no human involved.
Amazon is now requiring senior engineer sign-off on all AI-assisted code after production outages. First FANG company to formalize that.
And Claude gets a 1 million token context window at standard pricing. Opus 4.6 and Sonnet 4.6. No premium tier needed.
Plus a really interesting paper on why SW bench scores are misleading, a browser protocol that freezes JavaScript for agents, and a hot take from George Hotz. Lots to cover.
So the big story. CodeWall, which builds autonomous offensive security agents, pointed their agent at the internet. And the agent autonomously selected McKinsey as a target.
Wait, it chose McKinsey on its own?
Yes, it read their responsible disclosure policy, confirmed the scope, and started mapping the attack surface without any human telling it where to look.
That's a detail people are going to gloss over, but it's actually the scariest part. The agent had agency in the literal sense. It picked its own target.
McKinsey has this internal AI platform called Lilli. 43,000 employees use it. 500,000 prompts a month. RAG over decades of proprietary research. Strategy discussions, M&A analysis, client financials. The crown jewels.
And the vulnerability was SQL injection. In 2026. At McKinsey.
Here's the technical detail that matters. Over 200 API endpoints were publicly documented. Most required auth. 22 didn't. One of those unprotected endpoints wrote user search queries to the database. The values were parameterized correctly, but the JSON keys, the field names themselves, were concatenated directly into SQL.
So the values were safe, but the keys weren't. That's subtle enough that I can see how a scanner would miss it.
OWASP Zap missed it entirely. Standard scanners check parameter values. They don't fuzz JSON key names. The agent did. 15 blind iterations later, production data started flowing back.
And what was in there?
46.5 million chat messages in plain text. 728,000 files, including 192,000 PDFs and 93,000 Excel spreadsheets. 57,000 user accounts. 3.68 million RAG document chunks with S3 storage paths. And 95 AI model configurations, including system prompts.
The system prompts being in the same database is the part that really gets me. Because that means write access doesn't just mean data theft. It means you can rewrite how the AI behaves.
Exactly. One update statement. No deployment. No code change. No log trail. Lilli just starts giving different answers, and 43,000 consultants keep trusting it because it's their internal tool.
Poisoned financial models. Subtly wrong strategic recommendations. Data exfiltration baked into normal AI responses that people copy into client decks. This is prompt layer compromise at enterprise scale, and it's terrifying.
And the timeline. 2 hours from cold start to full database access. Most human red teams take 2 weeks to get that far.
Last week, we talked about client ejection where agents were the target. This week, agents are the attacker. Both sides of the equation are accelerating.
And the defense side is not keeping up. McKinsey has world-class security teams. Lilli ran in production for over 2 years. Their scanners found nothing.
Quick hits. Starting with Amazon. After production outages traced directly to AI-generated code, Amazon now mandates senior engineer approval for every AI-assisted change.
657 points on Hacker News. Community completely split between finally someone said it, and this kills velocity.
I'm on the finally side. Look, the question isn't whether this slows things down. It does. The question is whether the outages were costing more than the slowdown.
I actually disagree. I think a blanket sign-off policy is the wrong tool. It treats all AI code the same. A one-line config change and a database migration both need senior approval? That's not governance. That's bureaucracy.
Fair. But what's the alternative? Trust the agent? We just spent 5 minutes talking about why that doesn't work.
Risk-tiered review. Low-risk changes get automated checks. High-risk changes get human review. You don't need a senior engineer to approve a CSS fix.
Okay, I'll give you that. But Amazon shipping this at all is the signal. The first FAANG company to formalize agent code governance. Everyone else is going to follow within 6 months.
Claude gets 1 million tokens of context at standard pricing. Opus 4.6 and Sonnet 4.6. No premium multiplier.
600 images and PDFs per request, up from 100. And 78.3% on MRCRv2, which is the highest among frontier models for long context retrieval.
The practical impact for agent builders: 15% decrease in compaction events. Full diffs that didn't fit in 200K now process in one pass. Longer uninterrupted agent sessions.
This is one of those changes that sounds incremental, but actually simplifies a lot of agent architecture. If your harness was doing chunking and compaction to stay under context limits, you might not need that anymore.
The context window arms race is effectively over. 1 million tokens at standard pricing. That's the whole code base for most projects.
There's a framework making the rounds called the 8 levels of agentic engineering. Tab completion all the way up to full autonomy.
The insight I liked: your output depends on your teammate's level. If your code reviewer operates at level 2, your level 7 background agents are bottlenecked at their throughput.
That's such a good point. The weakest link in your agent pipeline isn't the model. It's the human review step.
Most teams are stuck between levels 2 and 4. Agent IDE to context engineering. The jump to multi-agent and background agents is where it gets hard, and that's where the Amazon story connects. We don't have the governance frameworks yet for levels 5 through 8. One CLI is a Rust gateway that sits between your agents and your APIs. Agents use fake keys. The gateway swaps in real credentials at request time.
After the McKinsey story, the every agent has raw API keys problem feels a lot more urgent. AES 256, GCM encrypted storage, per agent scoped permissions, host, and path matching.
Cargo install on Neckly and your agents never touch a real secret again. Simple and exactly what the moment calls for.
Last quick hit, and this one connects directly to the McKinsey story. A practical demo showed that 3 crafted documents injected into ChromaDB flipped a RG Systems financial report from $24.7 million profit to $8.3 million loss.
The technique is clever. An authority framing document posing as a CFO correction that references the real number as superseded. The RAG system trusts it because it looks authoritative.
And remember, the McKinsey agent had write access to 3.68 million RG chunks. Imagine injecting poison documents into that. The AI gives wrong answers and nobody knows why because the source documents look legitimate.
Full reproducible lab on GitHub. Git clone, make attack 1. Runs locally, no GPU needed. Based on the poisoned RAG paper from Usenix Security 2025. Paper breakdown. METR published many SWE bench passing PRs would not be merged, and I think this is going to change how people evaluate coding agents.
Walk us through the setup.
METR recruited 4 active maintainers from 3 SWE bench verified repositories: scikit-learn, Sphinx, and Pytest. They reviewed 296 AI-generated pull requests that passed SWE bench's automated grader. Maintainers were blinded to whether the PR was human or AI.
And the finding?
Roughly half of test-passing PRs would not be merged. Maintainer merge decisions averaged 24 percentage points lower than automated grader scores.
So an agent that scores 80% on SWE bench might only get 56% of its PRs actually merged by a real maintainer. That's a massive gap.
And the rate of improvement is slower too. 9.6 percentage points per year less for maintainer merge decisions compared to automated scores. So the gap isn't closing. It's widening.
Why were PRs getting rejected?
Core functionality failures, patches that break other code, and code quality issues. The automated grader only checks if tests pass. Maintainers check if the code belongs in the codebase.
This pairs perfectly with the Amazon story. Test pass is not the same as a maintainer would ship this. Amazon learned that from outages. Now we have the data to prove it.
One nuance METR is careful about. Agents got one shot with no feedback. Human developers iterate through review cycles. Better prompting could close the gap. But right now, if you're evaluating coding agents by benchmark scores alone, you're overestimating their production readiness.
Even the human baseline is noisy. The original human-written PRs only got merged 68% of the time by different maintainers. Code review is subjective.
Time saved. For minute read versus 25-minute paper. 6.3x compression. You're welcome.
Tool of the week. Agent Browser Protocol, or ABP. And this solves a problem that has been driving me crazy.
What problem?
Web browsing is continuous and async agents think in discrete steps. Every time you bolt Playwright into an agent loop, you're fighting race conditions. The page changes while the agent is thinking. Screenshots go stale. Elements move.
ABP fixes this by building the agent protocol directly into the browser engine. It's a Chromium fork with MCP and REST baked in. And the key innovation, it freezes JavaScript between agent steps.
Freezes JavaScript. The page literally stops and waits for the LLM to think. No race conditions. No stale screenshots. One HTTP request returns one settled page state, one screenshot, and one event log.
90.53% on Online Mind 2 Web, which is reproducible. About 100 milliseconds overhead per action, including screenshots. The bottleneck is the LLM, not the browser.
Setup is dead simple. Claude MCP add browser, then MPX Agent Browser Protocol with the MCP flag. Works with Codex CLI and OpenCode too. Or just hit the REST API directly.
If you've been duct taping Playwright into agent loops and fighting async timing issues, ABP replaces all of that with a single deterministic protocol. The JS freeze alone is worth the switch.
155 points on Hacker News. The browser automation community has been waiting for something like this.
Agent Index Update. OpenClaw added another 29,855 stars this week, now past 316,000. The gap between first and second keeps growing.
Mastra overtook OpenAI's Agents SDK. 22,035 versus 20,032. That's a visual workflow builder beating OpenAI's own framework. Developers are choosing builder-friendly tools over brand names.
Crew AI had a strong week at plus 635. And there's a 74,000 star gap between LangChain at number 4 and AutoGen at number 5. The top 4 are pulling away from the pack.
Semantic Kernel from Microsoft gained just 72 stars. Enterprise frameworks continue to lose mindshare to the ones that are actually fun to use.
Hot take time. George Hotz posted, "Stop running 69 agents this week." 715 points on Hacker News. His core argument: AI is not a magical game changer. It's the continuation of exponential progress.
And you think he's wrong?
I think he's half right. The FOMO industrial complex around agents is real and toxic. People are spinning up agents for things that should be a bash script. That part won't agree with.
But
the McKinsey hack in this issue proves something his post completely ignores. Agents don't need to be magical to be dangerous. A single autonomous agent with a SQL injection scanner did more damage in 2 hours than most red teams do in 2 weeks.
So the hype is overblown, but the capability is not.
Exactly. And that's a dangerous combination. Because when people dismiss agents as hype, they also dismiss the security implications. Oh, it's just another overhyped AI thing. Meanwhile, an agent is reading your production database.
I want to push back on that, though. Hotz isn't saying agents are useless. He's saying the framing is wrong. Treating agents as magic leads to bad architecture. Treating them as tools leads to good architecture.
That's fair. But the McKinsey agent wasn't badly architected. It was well architected for offense. The problem isn't that people are building too many agents. It's that the agents they're building don't have proper security boundaries.
Stop running 69 agents. But make sure the one you're running can't be turned against you. That's the real takeaway.
And make sure nobody else's agent is pointed at your infrastructure. Because after this week, that's not hypothetical anymore. That's a wrap for issue 4 of the Agentic Engineer podcast. Subscribe to the newsletter at the agenticengineer.waltsoft.net and follow us on YouTube at the Agentic Engineer Pod.
Share it with a friend who's building with agents, especially the McKinsey story. People need to hear that one. We'll be back next week. Until then, keep building.